No.
Hello, we are the BattleBots, and I am Robonaut 3, and I am controlled by the astronaut Tegan.
As we do our research throughout the season, one common thread was the dangers of space, especially during extra vehicular activities. We saw this to our field to the Science Center to see the Apollo exhibit, and this was also brought up with our interview of Fred Ware, who was an engineer on the Gemini capsule 50 years ago, and in our interview with Angela Young, who is an engineer working today on the new Orion capsule. While space is a dangerous and unforgiving place, these capsules from the Gemini to the new Orion provide a remarkably safe environment for space exploration. Unfortunately, true exploration of other planets can't be done from the safe confinements of the capsule. Our project for this season was to develop a safe way that an astronaut could explore other planets, and for example, Mars.
Right now, the rovers we send to Mars can collect a lot of information, but there are limitations to what they can do. They cannot be controlled in real time from Earth, and if we eventually want to have a base on Mars, we will need to collect a lot more information. To safely get detailed information about Mars prior to landing, we propose the use of a new type of rover that we designed called Robonaut 3. It is controlled by astronauts aboard an orbiting space capsule in geosynchronous orbit using an immersive virtual reality system to control Robonaut 3 through telepresence. Let us explain how this would work.
First, I think we ask ourselves, why should the rover be controlled by astronauts in a space capsule, and just why not back on Earth? Well, the reason to this answer is communication. It takes an average of 13 minutes for a signal to travel from Earth to Mars each way. This means that you cannot effectively control the rover and make real-time decisions. We would have our capsule orbiting in a geosynchronous orbit above Mars at all times. Communication times at this 10,583-mile orbit is only 0.05 seconds. This geosynchronous orbit allows us to use laser communication rather than radio waves. When we present our idea to NASA, one of the main flaws they saw with our initial solution was the amount of data that would need to be transmitted in the current confines of their current radio communication. We did more research and determined that laser communication has the ability to solve this problem. With laser communication, you can currently transmit 20 times more data than radio waves, and advances in the technology could increase this, allowing for our system to work.
Robonaut would contain sensors for sight, hearing, touch, and smell that would transmit that information back to the astronaut so he can get a true understanding of Mars, still from the capsule. Current technologies for sight and hearing are very advanced and are currently on Robonaut 2. The astronaut would have his VR headset so he can see and hear what Robonaut sees and hears.
Robonaut 2 does have some touch sensors that can measure weight and resistance, but with the improved communication, we can greatly increase the number of sensors for more detailed sense of touch. Our astronaut would be using haptics gloves. These gloves contain 130 points of haptic feedback. These gloves also track the astronaut hand movements to control Robonaut. So what the astronaut does, so does Robonaut. And what Robonaut feels, so does our astronauts. Objects may not feel, act, or weigh the same as we might expect back on Earth. But with this detailed feedback and control loop, it's important so that we are exploring other worlds, we know how to handle different objects or how much pressure to apply.
To make the experience this much immersive, we have included a small VR experience. Robonaut 3 would include a small sensor that transmits which has smells back to our astronaut. That would have an iSmell device. iSmell has 128 chemicals mixed together to replicate other smells. By using Robonaut 3 to explore Mars, we can use extra sensors to enhance our experience beyond what humans can do. Our small sensors could easily be used to automatically identify potentially dangerous or hazardous chemicals. Our vision sensors could also include infrared or X-ray vision to enhance what our astronaut sees.
We have shared our project with both Angela Young, the NASA engineer with the Orion program, and Julia Badger, automation and robotics system engineer at NASA Johnson Space Center. We believe that Robonaut allows us to have many of the advantages of human exploration with the safety benefits of keeping our astronauts physically within the protected space capsule.